Hello all, and welcome to On the Spot STEM. Today we will be tackling the USACO January 2019 problem number 2, IC perimeter. So the problem's essence is Farmer John has an n by n grid of ice cream where a hashtag character represents a 1 by 1 cell of ice cream and a dot represents no ice cream, an empty space. And so essentially the machine produces these disconnected blobs of ice cream, as you can see here, and a blob is connected if we can reach every other cell of ice cream in that blob through north, west, east, and south directions. So we just move in the four cardinal directions and see if we can get everyone in the blob. And so Farmer John wants to find the area and perimeter of the blob having the largest area. So the area of a blob represents the number of hashtag characters in that blob, and the perimeter is essentially the perimeter. We draw a kind of outline around the blob, and we want to calculate how lengthy that line is. So I'll go over that more later, and it gives some clarifications about what a blob is. It can be nested in another blob, and blobs can have holes in them too. And the thing about the hole is that the perimeter on the inside also counts towards the perimeter of the blob. And another thing at the end, something important, is if multiple blobs are tied for the largest area, print the information for whichever of these blobs has the smallest perimeter. So essentially, we want to use the flood fill algorithm here because our blobs are going to be very weird in a sense that we don't know what shape they're going to be. So we want to use a flood fill function where we traverse a blob by going from the square to its up, left, down, and right directions. So we want to traverse the blob, and we will obviously have like a global counter variable. We'll call it like area, where we go through the blob and we try to find, the maximum area of that blob over all the blobs in the square. So we call the flood fill function, and it's a recursive function, so it'll go up, left, right, and down until we reach the end of a blob, and we'll have essentially boundary conditions to check whether this function doesn't go outside of the grid, and we'll also kind of check whether if one of these four directions yields a dot instead of a hashtag, then we'll stop the flood fill as well. And so this will allow us to find the area. And the perimeter of the blob comes from this simple insight. It's essentially if you have, for example, this grid. So consider this hashtag. So this hashtag, what will it contribute to the perimeter? It'll contribute this side and it'll contribute this side to the perimeter, right? And the reason it contributes this side and this side is because those are the two sides that don't have hashtags next to them. In essence, if a side of a blob has a hashtag, that given side will not contribute to the perimeter. So if there are n hashtags next to a given square, then that square will contribute 4 minus n to the perimeter. So that's how we're going to calculate the perimeter, and we'll have another global variable for the perimeter, and we'll have a max perimeter variable as well. So yeah, that pretty much sums up the problem. We have to be conscientious of this output format, but other than that, it's fairly straightforward if you know the flood fill algorithm. And so I have my Eclipse here, and basically I've done the file input. Essentially, it's fairly straightforward. All you have to be careful of is making sure that this temp that I've defined here, st.nextToken, it reads the whole line, not just individual hashtags and dots. And we're just going to use the substring function as we loop through each row and each column of the grid. So that's the file input, file output. But the core of the problem is kind of the flood fill, right? So first, let's create our globals because we have to figure out what we're trying to count. So we want kind of a So when we're going through the flood fill, we want to make sure we don't go back and forth between two squares. So one important thing is an array that basically it's the checked array. It indicates true if we've already been to that square, if we've already checked that square, and false if we haven't. So let's do that. Checked. My bad. So checked. And let's initialize that down here to n by n. So let's call it checked equals new boolean, and this is just initializing the size. All right, so that's our checked array. That's important, of course. And we also need a area, kind of a, this is going to be our area variable. And so we kind of need an area variable. We also need a max area variable. This area variable is kind of going to be temporary because for each blob, we're going to have an area, but when we move to the next blob, we're going to find a new area. So this is going to be a temporary variable, kind of, for area, but we'll have a max area variable that will be stored between runs. So let's call it max area right there. And we need a perimeter variable as well. And we need a max perimeter variable as well, because it's a similar idea as the area things. So those are our globals, and now we got to think about the flood fill itself. So we're gonna clear it. I'm gonna create a flood fill method down here. So this flood fill method, so it's not going to return anything because it's just going to be traversing the grid and trying to find the areas and perimeters of blobs. And those are already stored in our globals, so we don't have to worry about that. So let's see. Let's call it flood fill. And what do we need? Well, we need a kind of a starting position, which will be int, call it row. We need a also a column. And then we need to pass in the grid as well. I could have stored this as a global, but I didn't. It's okay. I'm not going to change it now because I've already set it up. So basically, we have a given square, and we need to think about the up, left, right, and down. So I'm going to define that real quick. So int up. So up is going to be, that's going to be row minus 1. It's going to be the square right above. And then we're going to have int down, which would be row plus 1. We're going to have int left, which is col minus 1. We're going to have int right, which is col plus 1. So, and one thing we have to think about is, so if we've called this flood fill function, what that means is that we have visited this square, this hashtag, this given hashtag, and that we're counting it in our area calculation. That means we need to do area plus plus, because what this means is that we have passed through this square and we need to add it to our kind of total of whatever blob that we're in. And one other thing we need to do is, because we've kind of visited this square, that means checked. That means we've checked this given square, right? So checked of row and column will be true. And the good thing about initializing checked here is that a Boolean initializes to false. So essentially, we just set this as true and we're good. So now the actual flood fill itself and the recursive part of it. So what we need to do is, so let's just consider the up case, and then I'll just copy and paste the right, left, and down cases because they're analogous, of course. So what we need to check is, are we going out of bounds first? That's what we need to check first, and it should short circuit if we go out of bounds. So we need to check, well, since up is row minus 1 and row is already in bounds, we just need to check whether up is greater than or equal to 0. If that's true, and grid up, so we're going to a different row, but the column remains the same. And if this is equal to 1, so what I forgot to mention is that I defined the hashtag as 1, and I defined the dot as 0. So this essentially indicates that if our square is in bounds and it's a hashtag, then we're good. And we also need, well, the thing is we don't want to alternate back and forth between squares we've already checked. So we also need to check that checked of up and column is equals to false, because if it's true, then we've already checked that and it's already in our counter. So once we've done this, we've checked that it's safe to flood fill the square that's above. So we can do flood fill of up, call, and grid. So this essentially will repeat the function on the square above. Now, one thing we also need to check is perimeter things, because we need to check whether since we flood filled this square, we need to see how much it contributes to the perimeter. So what we kind of need to do is we need to see for the given square that we're in, how many squares are hashtags around it, right? So let's essentially have a count variable to count how many of those squares around it are part of our hashtags. So we need to check that. Well, first we need to have this short circuit condition, of course. So once we put this in, that's all we need to check, right? What we're checking here is that first, the square is in bounds, and secondly, if the square is in bounds, if that square is a hashtag, then we're going to increase count. So we've initialized to 0, and this essentially says that the square above is a hashtag and we're increasing the count. So I'm not going to do the same thing for the left, right, and down squares because it's pretty much analogous. So I'm just going to copy and paste it from the code that I already have for this. So right there, put that in. That's the left case. Now let's put in the down case. Here's the down. This is continuing to fill the grid. And the idea, of course, remains the same, except when you have the down and the right squares, it's basically, you're going to check the upper bounds of the grid and not the lower bounds. All right, so now we've kind of filled everything. But the problem is we have to think about our perimeter. So we have this temporary variable for perimeter, and we need to add to it, right? We've added to our area, but we also need to add to our perimeter. So adding to our perimeter is like this. So count is the number of hashtags around the square, and we know that 4 minus count will contribute to the perimeter. So we can add perimeter plus equals. So we're adding 4 minus count, 4 minus the number of hashtag squares to the perimeter. So that's what that does. And so now we've created our flood fill, we can think about the algorithm itself. And this is actually pretty straightforward. All we just want to do is go through the whole grid. And since the grid is, of course, n by n, and the problem says that n is going to be less than 1,000, an O of n squared algorithm is fine. So let's start by doing that. So let's create our loop. This is just going to be our row column traversing through the array loop. And then after that, we'll implement the flood fill. So one thing we might want to do also is initialize area to 0, because actually we don't need to do that yet. We can just do that later. So now I just did the row code, and now I'm doing the column loop. So I am running out of time on my screen recorder. It's like 15 minutes nearly. So I'm going to stop this video here and we'll continue for part 2. So goodbye and see you in the next video.